Okay, for this one, we're going to be looking at PAN14, which is rational numbers versus irrational numbers, and being able to decide which one is which whenever you're looking at a number. Um, you've probably seen lots of rational numbers, so I'll talk about those first. These are going to be uh, most numbers you've seen, almost any of them. They can be written as a fraction. Very important. Just memorize. Uh, the fraction you see that people will write for them is something that's like a over b, where a and b are integers, and b is never zero. If you aren't sure what integers are, I'll do those off to the side. That's kind of the symbol for it, good as I could do right now. I'm gonna put some dots so you know it doesn't start here. And it's gonna be any number that's a whole number, whether it's positive or negative. Um, stuff like 1, 2, 3, -1, -2, -3, and you just make fractions out of those. One that you've probably seen, the number something like 5 is the same as 5 over 1. Those fits the rule. 1 and 5 are both on this list over here, so you're good to go. Decimal numbers like 0.5 is the same thing as 1 over 2, and that's once again two integers on top of each other. So make sure you know what a fraction looks like, make sure you know what the integers look like. That's how you make any rational number. Other stuff you might need to know about rationals. Um, the decimals that you're going to be seeing for them can repeat the numbers. You'll see that a lot. One that's pretty important is 1/3 is the same thing as 0.333, and the threes just keep coming. Um, it's still a rational number because 1 over 3 is two integers and it's a fraction. So when you get the decimal, no matter what it is, you know it's going to be rational. Some numbers get weird, like 1 over 7 is 0.1428571 so the 142857 keeps repeating. It repeats this whole thing. It's kind of hard to notice, but you'll know that it's a rational number because you can write it as a fraction. Um, there's other ones that are even harder to tell, like 1 over 11 is 0.090909. Zero nines keep going. They repeat forever. So even though it goes on forever and repeats, it is still rational because it's a fraction. Mostly every number you've seen is going to be irrational. There are tons that you could think of. Lots of rational numbers. Make that R better. Um, either way, that's the main one you see. You see it a lot. You're going to see it a lot. The one you need to watch out for is irrationals. There's a couple rules that you're going to need to know for these. If you see a decimal that doesn't have a pattern, like no repeating, no pattern to it, that's going to be an irrational number. It's hard to give examples of that, so you just know it when you see it. If you're looking at a decimal and there's nothing that looks like it repeats, then it's probably irrational. You can't write these as fractions. So If you see a number that is written as a fraction, you know that it's rational because these cannot be written as a fraction. You don't see these a lot. Um, they're just not very common. There's other times where you see them, they're a little bit easier to describe. Um, there's a couple more things. Irrational numbers are numbers that you write as a symbol. One that I know everybody has seen is probably pi. It's 3.1415 and it keeps going. I don't know the whole decimal, but there's no real pattern to it. You just have to memorize it, and that's the only way people know it. If you see a number and it's written in a weird symbol, then it is probably irrational, um, even if you know the decimal. Another one that's important is square roots of negative numbers. Something like the square root of negative 4. The square root of 4 is 2, but the square root of negative 4 is irrational, and you cannot get an answer for that until you get to algebra 2. Maybe algebra 1. Just depends how far they go. Either way, square roots are a good place to look for irrationals. Another one is square roots of any number that's not a perfect square. If you don't know what perfect squares are, I could write those off to the side. It kind of goes along with the integers. It's, stuff like 1, 4, 9, 16, 25, and so on. So if you're looking at a square root and it's not one of these numbers, then you know it's irrational. You know it's one of these numbers if you look at it and this number is 1 squared, this one's 2 squared, 3 squared, and so on. You just, use whole numbers and you square them, and that will give you perfect squares. If, you could type something like, let me do an example. You could type the square root of 4 in on the calculator and you get an answer like 2. But if you type the square root of 2 in, you get 1.41 something. It keeps going. It's a weird decimal. This one's irrational. But the square root of 4 is rational. Um, the square root of 2 is irrational because the perfect squares are 1 and 4. 2 is in between 1 and 4, so that's going to be the square root of something that's not a perfect square, which will give you an irrational number. Those are important places to look. There are a couple more, but for the most part, that's going to be just about anything that you'll see. So make sure you recognize them and identify them when you need to. Thank you. Email me if you have any questions.